Thank you guys, and thanks for joining us today. My name is Elaine Zelby. I lead product marketing at ConsenSys, and the panel today is on Ethereum's roadmap. So we're going to cover fun topics like Casper and sharding and plasma and much more. But first, if we can do a quick round of introductions from our awesome panel.
Hi, I'm Bharath Rao. I'm the CEO of Leverj. It's a decentralized exchange based on plasma that runs at centralized speeds.
Hey, my name is Alessandro Voto. I go by Alex. I'm actually also with ConsenSys, but a large part of my time is spent with the Enterprise Ethereum Alliance. So today I kind of want to give everyone a glimpse of what's going on inside the EEA.
I am John Wolpert. I was once part of the founder team of IBM Blockchain and Hyperledger, and now I'm at ConsenSys Imagineering.
Awesome, thanks guys. So when we think about the Ethereum roadmap, there are two big buckets that people are talking about in the short term. One is around this move from a proof of work consensus algorithm to a proof of stake, known as Casper. And the second is around the scalability challenges. So yesterday, if you heard the talk by Sam Cassatt, talked a little bit about the scalability trilemma. So you can solve for two of three things. You have at one end of the triangle, scalability. The other end of the triangle, you have decentralization, and the third, security. And Ethereum, when it was created, optimized around security and decentralization, and now they're working on a lot of things around the scalability part. Let's first start talking about the proof of work to proof of stake, also known as Casper. Just one of you guys want to take explaining what that is and why we're working on that today in Ethereum?
Yeah, so proof of work is the original consensus mechanism, and some people believe that it takes a lot of resources, a lot of time, it has uncertain finality, and therefore the idea is we go towards proof of stake. And there is some proof of stake coins from the very beginning of the, the history of crypto, and Casper is a way of doing this using bonds and making sure that you use game theory to enable much faster and a higher throughput without actually increasing the cost in terms of electricity and so on. It's still very, it's still experimental, but once it catches on, I think it could make a big difference in terms of how fast transactions flow through.
One other thing that I've heard mentioned a lot around transitioning to proof of stake is it makes it more decentralized or has a little bit more democratization in the system to allow people to participate, as opposed to what we've seen with the aggregation of miners in more centralized fashions. So what do you guys think in terms of, is this going to be something that democratizes access to securing the network?
Well, I mean, so Ethereum already kind of took a step forward with creating like a memory hard, like mining algorithm. So I think that was at least a slight improvement, but I think it's going to be interesting to see if financial access is really the thing that is the driving force behind decentralization. I think it's yet to be seen exactly how that pans out. I know that a lot of the struggle that the research team is focusing on is parameterization and really trying to figure out exactly when someone should be able to participate and what the limits on someone's power in that system could be. So yeah, it'll be interesting to just see how it pans out. This is why it's basically a hard problem that is going to persist through 2018. And I think of the FFG approach versus others, I think we'll get something helping on the finality side early on. But the major issue of all this is likely to be resolved, I think, in 2019 sometime.
I actually think that the proof of stake will work technology-wise, but how it will work economics-wise is something we don't know. What will happen when there are people with huge stakes of Ethereum? Is the game theory robust enough to ensure that things don't get out of hand? Will there be an oligarchy? All of these things are concerns, and the ETH community is well aware of it. They are working to mitigate these issues, and we'll see as it progresses how far it comes to the ideal that we want it to be.
Yeah, I'll zoom out a little bit and just say that I think those were, the question was well answered. The only thing I would add is that I like the idea of an Ethereum that has started and bootstrapped originally with proof of work, and now is going to the so that of maintaining decentralization and enhancing that. and getting past, while also scaling. Starting with some of these alternative methods is more troubling. So I think Ethereum has this nice history of already having been there, bootstrapped itself, got to an arguably large distributed state, and now is taking the next step. If you miss that step, you could trip.
I think what's nice is that we'll get a glimpse of how how at least a piece of this works once we get like the friendly finality gadget working with kind of a hybrid proof of work and proof of stake model.
Do you want to explain that a little bit for the audience of what that looks like today?
I think probably Bharath might be able to better explain this stuff, but I mean, it's interesting that at least it's a bit of a transition where we have basically just the way that we're all used to trusting the network with actual computation power backing it, but at certain checkpoints, we have folks who are randomly selected to basically put a stake in the ground and say that's where finality lies. There would be a way to parameterize and slash deposits if folks lie about that, and we'll see how governance works for challenging those folks and actually determining when bad actors actually play out on that. So we'll get to experiment with some of those in a way that is on the main net, even though some of these things are already working in the test net, in some test nets, and just get to actually get a flavor for it before we get fully roll out into a financially kind of slashed system.
Sounds like good baby steps in the right direction. Mm-hmm. So let's talk a little bit about the scalability solution. So Bharath, you are very, very ingrained in the plasma world. Can you explain for the audience what plasma is and what are the things that you're focusing on right now?
Let's get a quick temperature of the room here. How many of you are developers?
Okay. Call me no, sorry.
So, so I'll just modulate this for the audience. If you want a little bit of a backstory of how plasma came to be, there have been many great ideas in the blockchain space from the very beginning, of the Bitcoin white paper. Things like fraud proofs and state channels, and all of these were just ideas, and they were never realized because they were all just a single piece of a puzzle. And with plasma, all of these pieces came together, and it was the first time that entire bunches of teams jumped on and tried to make it happen. And this is because each of those pieces by itself, while it was interesting, it was not viable for any team to put resources to move forward. Plasma, as you guys may know, is from Joseph Poon, who wrote the Lightning paper, and Vitalik, who is, he's Vitalik, right? So it's a very comprehensive paper. It's pretty, they've gone into depth into what can be done. And I think most teams realize it's a lot, so they try to do the minimum possible. So what we as an exchange did was we realized that what people want is something very straightforward, right? You want to be able to place orders. You want those orders to fill without you being online. Like if you have to be online because something has to match and some transaction has to be sent across, you have to countersign it, it's just not going to take off. So we created a version of Plasma called Glow Plasma that enables trading at high speeds, and the only time you're going to have a footprint on the blockchain is when you deposit or withdraw. And I think the great thing about this is it can scale indefinitely. There's no blockchain limit to how much you can scale. It's just network infrastructure, latency, ping latency, all of this stuff. So the regular things that have already been dealt with by other big products like Google and Facebook and so on. So we are really at the cusp of seeing a huge, huge scale in the Ethereum world. And we're going to start with exchanges, and soon I think all of the dApps will also move into this, giving us the first real breakthrough beyond the initial early stage of blockchain economy.
This is a big deal. In 2015, very quick history lesson, my team at IBM, we decided to break with Ethereum. We wanted Ethereum to be the next, for us, Java, something that we didn't invent, but that we got behind, got to be the rich uncle and make lots of money. And we didn't go that way, and the reason was, at the time, the community was really into some things like scaling, and things that needed to happen, and we thought that getting into, I'm not going to call it privacy, I'm going to call it confidentiality. And I distinguish the two this way. Privacy can be about obfuscating attributes of a transaction, like the amount or the previous balances or the post balance, things like that, right? Not just the identity. And you can do that with, things like ZK, SNARK, and others. But you still have the logic of the smart contract. Even if you don't have the parameters in the clear, you have the logic of it in the clear. And you have the existence of both the smart contract and the transaction on a ledger everybody sees. Even in a private network, like a quorum network, you have everybody in that network sees what, so you're all, it's a nudist colony, right? Everybody's everybody's naked. And if you think about it, think about in business, in any kind of business, small companies, large companies, doesn't matter. In industry, I don't like to call it enterprise. In industry, if you're in the pharmaceutical industry, even if you're a small company, you have a contract with somebody else for a special price or some kind of set of business rules, right? And usually in that agreement, that legal agreement, it says, not only are the terms of this agreement confidential, the existence of the contract itself is also confidential. So now you're going to put this into a smart contract, the logic of it, and put it on even a private blockchain is not okay if there are competitors in that private network, right? So Hyperledger Fabric was born out of the need to create what we called channels at the time. The problem is, unless you have code coordination with channels, which you don't, and that's not something a lot of people know about Fabric, if you can, where you could take a smart contract on one channel and pass parameters to another one and back to the other one, and now you've got race conditions and you've got deadlocks and other, you can't do it. So you basically have everybody, even on that one channel, you've just driven the problem down. Now, just to make a long story longer, with Plasma and now with something I put on my Twitter feed, if you go to @jwolpert on Twitter, you'll find a link right now to Peter Robinson's work that even extends this notion of Plasma. Because Plasma, Joseph, is really interested in maintaining the integrity of a token, and that's a key part of this. But what we really want to get to is a point where I can have I can have an agreement with you that is prevented by some mainnet, which has tamper resistance power, such that you and I are the only ones running that agreement, the logic of that agreement. We only know about it. The outputs of that can go to a multilateral agreement on some other network, which then goes to another, maybe a public thing, and now Ether is being moved around. But why Ether is being moved around is not known, because you don't need to know about our special deal, right? That's the world we need to get to, and that's why this Ethereum roadmap is exciting. So I guess my plug is, if you're trying to learn blockchain, don't learn it on these walled garden things. Learn it on Ethereum, because that's where Ethereum's going, and that is the Internet of Transactions.
I think the roadmap for Ethereum looks similar, but also different when you think about in the enterprise versus the public net. And Alex, you work with the EEA. You have a lot of insight into what that roadmap looks like on the enterprise side. Can you talk a little bit about that?
Yeah, so the role I've played in the EEA thus far has kind of been surfacing some of these working groups, which we're now calling special interest groups in the EEA, for folks to talk to each other and actually find common problems they're running into, develop common frameworks for how to deal with problems and develop solutions, and then ultimately actually bubble those industry level needs up to technical specification that we released the V1.0 of at ConsenSys this year. So now we're working toward version 2.0 of that, which will be announced very shortly. So in the enterprise, I mean, people are basically faced with these issues that have yet to be addressed in a really substantial way on Ethereum in a way that would enable the kind of transaction throughput that might be necessary. And a lot of the important things like Plasma are pushing forward on the research angle, but there are some immediate enterprise needs that folks are making compromises for in the present. So the goal with the specification, sort of the direction of the EEA, is to just create a general specification on what must be true of any Ethereum implementation, as far as privacy goes, as far as scalability goes, as far as the ability to actually, to enable kind of integration with legacy software. So we're trying to figure out, what must be in there, what should be in there, what may be in there, and actually kind of drive all that down. And along the way, folks are starting to realize that they have come across this sort of similar problems. And so we're just starting to see that collaboration kind of bubble up. It's been a slow process because I think folks have been doing things in isolation for so long, and actually even just the mental transition of them operating on the same test net, of not owning the network, not owning the blockchain, not having to do a full custom, sort of entirely new system that they get a PR report on. The idea that what they should be doing is creating highly interoperable implementations, working on things where you can port data from one element to another, which gets back to what John was mentioning. That's kind of the vision, the goal. And what I'm really, really excited about is, first of all, encouraging people to play with the public net before even considering, a private network. There's a lot that you can do that folks, I think, take for granted since they've been sort of told that enterprise Ethereum is a private network. There's quite a bit that you can do in the clear, transparently. There are a lot of new privacy approaches. These state channels, EK snarks related stuff that allows for you to do a lot more. And the frontier is being pushed forward on trusted execution environments and even more advanced ways of actually dealing with private information and smart contracts. So what I'm really excited about is this convergence of private networks and the power of the public chain and the safety of the public chain, encouraging people to play in both worlds. And then once we actually get side chains and all these different kinds of networks, that folks will really feel the power of what feels more like an internet rather than a set of disjointed and bilaterally connected intranets.
If I can just add one thing to that, since Ron Resnick took over especially, I think it's exciting to see EEA becoming this kind of standards body. I like that they've branded EEA and not Enterprise Ethereum so much. It's EEA, and that they're a spec dev organization, so that I think that, if anybody's building like a consortium in the room or on camera, think about this. You've got all these cats out there, the Walmarts, the Maersks, and what are they doing? They're building these networks, these private networks, which are interesting, and there's nothing wrong with that, but it kind of reminds me of HyperCard back in 1992, right? It's like this purpose-built thing, and I could make links, but then HTML came, and I was like, oh, well, I guess I'll move that over. So Hyperledger might be to blockchain what HyperCard was to HTML, I don't know. But now, the clever people out here are going to do is you're going to go and you're going to create your consortium first as a ERC. You're going to define your spec, and then you're going to publish that through the EEA. And now FNAME is what everybody's going to use for that field header, and these kinds of specifications will be standards. And that's way better than some private network for supply chain.
Yeah, and what's cool is, so that specification is for any enterprise-grade Ethereum client to be stamped with approval, where you can basically say, I can trust this because I know that it represents the values and the current state of research in the enterprise space on what makes an Ethereum chain safe and usable. And what else is cool is from each of these special interest groups, like I said, there are going to be bubbling up requirements that are industry specific. So one Ethereum client might be totally sufficient for an advertising use case, but in a medical context, maybe there's a whole other burden of privacy, or there should be. In the financial context, a whole other sort of set of needs. Now those shoulds now become musts around privacy and transaction finality and stuff. So it's cool to see each of these industries sort of mention what is really important to them and collectively drive what all these different client implementations are going to aim to do, all while making, ideally heightening the ability to make interoperable clients.
To play a little bit further on that, John, you wrote a blog post recently where you made a prediction that by 2020, there will be this convergence of public and private chains. So I'm curious to hear you talk a little bit about what needs to happen both from a technological perspective, but also from a cultural shift to make that a reality.
Especially because I've taken up a lot of time, I think I'm going to punt that over to Bharath, because you are doing that. You are converging public and private in a beautiful way, and I'd like to hear more about it.
Okay. So the way I look at it is that when something is private, it has a smaller network effect, right? So it's like the intranets of the mid-90s, and it has some value. But as someone who wants to create a network, someone who wants to create value, it is in your interest to create the biggest, widest network possible. The only reason we are, we are doing Plasma as a side chain is because in many applications, there is an internal economy that, is a significant part of the economic activity. For example, in trading, you deposit money, you trade around in that exchange for quite a while, and then you take it out. There is no reason that cannot be a separate side chain. And that enables you to separate those activities into separate side chain and enable the larger network to only come into play when something needs to move out of that network. So just like the internet is a network of networks, the global Ethereum chain will become a chain of chains, and
the mainnet becomes like the umpire, right?
Right. The umpire, or it's the global state, and you go into every sidechain can have its own rules. It can have its own consensus mechanisms, own finality needs, its own privacy features. I mean, anything you want, and this enables people to innovate without being impeded by someone else's constraints. So in that manner, I think convergence is already here, right? Once you have one or two Plasma chains, dApps working and running and getting traction, it will form its own network effect. For example, our exchange gets some traction, there's no reason for other exchanges to create their own network. Their interests and their incentives are aligned with simply joining our network, because then you can share the same liquidity pool, you can have a shared order book, and so on. And this, I think, will happen in all the various fields. In medicine, like medical records, do you really need to have 20 different pools of medical records? It just wouldn't make sense. So this network effect is, and the cultural shift will be driven by obvious incentives. People will see that building my own thing from scratch is just a lot more work, and whereas I could just join this thing that already exists. And because something is already in place for you to take advantage of, it will, I believe, shift the culture a lot faster than we expect. It will look slow, and suddenly it will just shoot up.
Yeah, it's not reinventing the wheel over and over and over again.
Exactly.
One quick note is, what's really cool about these sorts of things is like relay networks and different approaches to actually, like merging chains. Even Joseph Chow from ConsenSys did in 2016, he did BTC Relay and demonstrated that you can actually have meaningful interaction between Bitcoin and Ethereum and sort of trigger events. And what's motivating to me is right now that the blockchain space has been just so fragmented, and everyone's having to sort of choose between different implementations solely on the merit of like their developer community and all these other things. And what's really exciting is groups like TrueBit working on the Doge Ethereum bridge, which was like fun and lighthearted, but had an important kind of motive behind it. And all the work that's been done, Grid Plus and others on relaying and everything. I would love to see Hyperledger, Ethereum, Bitcoin, all these other sorts of systems at least be able to interact in some meaningful ways, so that no matter what an enterprise or no matter what a normal user would choose, they can still play and actually share resources and activate things on other chains. So that's part of the motivation in the spec. There's a portion of it that talks about interchain protocols, and it just says yeah, that should happen. That should absolutely happen. But the book we still need to write that part.
Hashtag convergence.
Yeah, it's exciting. For those of us that have been in the space, I was first getting into this. Everyone has their own origin story on this stuff, but I was in 2011. I believed that we would see these things actually start to come together much quicker, and so I'm really excited to see that part of the spec be written out, and for that to involve folks from outside the Ethereum space, talking about how they want to actually leverage what Ethereum's doing and bring what they have to bear, and vice versa.
Yeah, I'm old now, and I don't know how I got to be old, but I did. And 1969, first packet goes from LA to Menlo Park. I was there, and I was young, but I was there. You know, I don't think we're in 1993. Somebody said, I was on stage the other day saying 1993, and I'm like, I think 2 years ago you said the same date. So what's going on there?
I was a
I don't
futurist. We
think-
call that a rolling forecast. You know,
Right,
you're
the
just
rolling
like,
forecast.
oh yeah,
Or no, this is
we're
the static
close.
forecast. It's the, you know, we still seem to be stuck at 1993. I think the reason is it's really 1980s somewhere, maybe 70s. We've got a long way to go, and we're going to go through epochs of divergence and convergence, and it's okay. And I think we're hopefully on a path of convergence right now. I think that the next few years will be convergence. And I think it turns on the question of security. So all the cats in the public world, they talk about security and say, nobody's ever hacked our thing. Well, that's fine. That's about tamper resistance, and that's one half of security. I don't want to sound all wise here, but I think this seems obvious to me that that's only one half. The other part is surveillance resistance, something that, you know, if anybody's been paying attention lately, is also kind of important. Surveillance resistance, sometimes I shouldn't know what you're doing, right? That, you know, the best thing you've got for that is like an Oracle database behind a whole bunch of firewalls, right? The problem is with that, there's zero tamper resistance. If I've got the private keys to that database, I can tamper with it. So how can you get the tamper resistance of a public mainnet with the surveillance resistance of a private interaction peer-to-peer between two things? And that's what these guys are doing. That's what we're talking about. That, to me, that's what this round of convergence is all about.
I mean, to an extent, you know, Monero already has it, Zcash has it. I don't think it's unsolved
Zcash
problem.
doesn't really have it. It doesn't have logic segregation. It just has obfuscation of properties.
Right, right. And you know, this is still a developing field. It's still a research topic. It's not an entirely unsolved problem. The bigger issue, I think, is the speed. You know, you want to be able to do this at high throughput. Today, I could use, you know, Zk Starks or something like that to do a bunch of obfuscation, but you know, they won't have the same throughput that they have with like a regular trading application. And there are people working on this, and the math of that is not something I think we can accelerate. You know, it's something that has to someone has to create a breakthrough. So even today, I think with Zcash, like most of the transactions are not obfuscated.
Yeah.
They're you know, because it's just too slow to do the. So convergence again is not a point. I think maybe it's just it's a journey, and maybe it's not 2020. It starts at 2020, and could be 2030 before we are fully satisfied that this has converged.
You're really old then.
Yeah, but it would be good to see all the crypto be one again. You know, like it won't matter if you had Bitcoin or some Dogecoin or something else like that. You could use the best properties of every coin you want. You know, that would be a great future to be in, and have things converted at will at high speed, and you know.
That went fast, and I know we could probably spend about 3 hours talking about this, but I think for me, I find the more I learn and the more I know, the less I know. And there's a lot of moving pieces, a lot of things that will be an ever-moving target, but I think hopefully in the near future we'll see this convergence and chain of chains and the internet of blockchains, and lots to look forward to. So thank you all so much for your insights, and hope you guys enjoyed the session.
Thanks.